In this lesson, we're going to be talking about making payloads using Metasploit. A payload is something that you would inject into a vulnerable application, and the payload would probably give you some sort of shell access or provide a way to give you information or do something other than what the program was originally intended to do. Metasploit comes with a utility that's called MSF Payload, and I can just do MSF Payload -H. It's going to give me help. And you can see here I've got options, I've got the payload type, I've got variables, and then I've got the different ways that we can actually output that payload. This is the help banner. And now what I want to do is I want to figure out what I can actually use for payloads. I'm going to do a list, and it's going to give me all of the payloads that it has available that it can output in these different ways. So we've got C and Perl, Ruby, Raw, we've got executables, DLLs, and so forth. Here's all of the payloads that I have available. These are all of the payloads that you would normally find in Metasploit if you were trying to run an exploit and you wanted to change the payload type. This is the same list that you would get there. What I want to do here is I actually want to do something like a shell reverse TCP. Connect back to attacker and spawn a command shell. So the first thing I need to do here is I need to figure out what my IP address is. So now I'm going to do MSF Payload, and it's Windows, and I want the options for it. The O gives me all of the options that I've got available. You remember when we were looking before at the help, there were variables that I could set on the command line. Now the options, this is the same thing if I were to do show options when I'm in Metasploit. I've got the same thing here. This is a reverse TCP inline payload, and we've got the exit function, and that's going to be a process. I have a local host and a local port. Let's leave the local port alone, and I'm going to run MSF Payload, and I'm going to use Windows, and now I want to set the local host to my local host, which is the host that it's actually going to be listening on. And I'm actually going to set it to this one, even though this actually isn't going to work given the fact that we're doing a Windows reverse shell. I'm going to set it to mine. I'm going to leave the local port alone. And in this case, just to show you what we get for output, I'm going to do C output. This is going to generate the payload, and it's actually going to generate C source code that I could then use to add different functions or different code to, and the payload would be there. Shell reverse TCP. You'll see that the source code comes up in C, and the code that I'm actually going to get is setting a couple of variables to hexadecimal codes that actually are the executable or the machine language that could actually be executed. We've got a buffer variable here. As I said, this is all of the hexadecimal here that is actually the machine code that could be dumped into memory in a particular place. And if we set the instruction pointer correctly, we would actually execute this, and this would run our reverse TCP shell. I can also do this in Ruby as an example. I could do it in Perl as well. I could also just dump out an executable that would have this particular function in it. I'm going to generate Ruby, and it's going to give me the same sort of thing here. You can see we've got the buffer, and really it just sets the buffer variable in a Ruby style. That's how you would use MSF Payload in order to create payloads that you could then use to write your own exploits. Rather than having to go figure out how to create a payload, Metasploit will actually create a payload for you. Then you could actually just implement that program into your exploit code yourself. And you would have the payload that would, in this case, do a TCP shell, or there are a number of other things that you could use as well. MSF payload is good for when you're writing your own exploits and you need some payload shellcode in order to dump into the executable that you're writing.